Question 51. Federal regulations set up an upper limit of 50 parts per million of ammonia in the air in a work environment, that is 50 milliliter ammonia per 10 to the power 6 milliliter of air. The density of ammonia at room temperature is 0.771 gram per liter. Air from a manufacturing operation was drawn through a solution containing 100 milliliter of 0.0105 M HCl. The ammonia reacts with HCl as follows: ammonia plus HCl forming ammonium chloride. After drawing air through the acid solution for 10 minutes at a rate of 10 liters per minute, the acid was titrated. The remaining acid required 13.1 milliliter of 0.0588 M NaOH to reach the equivalence point. A part: how many grams of ammonia were drawn into the acid solution? B part: how many parts per million of ammonia were in the air? C part: is this manufacturer in compliance with regulations? Now, milliequivalents of ammonia will be equal to milliequivalents of HCl, or equivalents of ammonia will be equal to equivalents of HCl, which is used up in the reaction with ammonia. Now, equivalents of HCl used up in this reaction will be equal to equivalents of HCl present at the beginning of the reaction minus equivalents of HCl which is left at the end of the reaction. Now, equivalents of HCl which is left at the end of the reaction will be equal to equivalents of NaOH. The amount of air which is drawn through the acid solution in 10 minutes will be 10 into 10, that is 100 liters. Now, solving this question, first, equivalents of HCl present is equal to molarity of HCl, that is 0.0105 M, into volume of HCl in liters, that is 100 by 1000 liters, into valency factor of HCl, that is 1, and this is equal to 0.00105 equivalents. Now, equivalents of HCl remaining after the reaction will be equal to equivalents of NaOH, and equivalents of NaOH will be equal to molarity of NaOH, that is 0.0588 M, into volume of NaOH, that is 13.1 divided by 1000 liters, into valency factor of NaOH, that is 1, and this is equal to 0.00077028 equivalents. Therefore, equivalents of ammonia will be equal to equivalents of HCl present minus equivalents of HCl remaining, that is 0.00105 minus 0.00077028, and this is equal to 0.0002797 equivalents. Now, from this, weight of ammonia will be equal to equivalents of ammonia, that is 0.0002797 into equivalent weight of ammonia, that is 17, and this is equal to 0.00475 gram. Therefore, the answer to the first part of the question is 0.00475 gram. Now, the B part, how many parts per million of ammonia were in the air? Now, in 1 minute, amount of air that was drawn is 10 liters. Therefore, in 10 minutes, the amount of air drawn will be equal to 10 into 10, which is equal to 100 liters, and this is also equal to 100 into 1000 milliliters. Now, weight of ammonia is equal to 0.00475 gram. Density of ammonia is equal to 0.771 grams per liter. Therefore, volume of ammonia will be equal to mass by density, that is 0.00475 divided by 0.771, and this is equal to 0.00616 liters, and this is also equal to 0.00616 into 1000 milliliters. Therefore, the volume of ammonia in 100 into 1000 milliliter of air is 0.00616 into 1000 milliliter. That is, volume of ammonia in 100 into 1000 milliliter of air is 0.00616 into 1000 milliliters. Therefore, volume of ammonia in 10 to the power 6 milliliters of air will be 0.00616 into 1000 divided by 100 into 1000 into 10 to the power 6. Solving this, the value is equal to 61.6 milliliter. Therefore, in 10 to the power 6 milliliter of air, the amount of ammonia present is 61.6 milliliter, or it can also be said that amount of ammonia present in air is 61.6 parts per million. Now, the C part of the question, is this manufacturer in compliance with regulation? The answer is no, because the amount of ammonia which is allowed is 50 parts per million, but amount of ammonia present is 61.6 parts per million. Therefore, answer is no.